Hi, everybody. Welcome to our second to last training session. Congratulations at making it this far. So, today we are going to talk about programming concepts within SQL Server. Up to this point, we've been writing SQL scripts, we've been writing general, but we haven't done a lot of what traditional programmers might consider structures and things. So let's go ahead and get started. Usual disclaimers. All right, so here's kind of what we've done, where we're going, right? We've done we've done select tables and data structures, we've done reporting functions, and then we did temporary things where we talked about temp tables and variables and right, all those sorts of things. And then today in the programming one, we're definitely going to add some new things that you can do, but we're sort of culminating most of these things that we've learned so that we can do more with them, right? We can start applying business logic. We can start doing error handling. We can start doing these things to help make our code more resilient and beneficial to be a true component of an application or of a report or a website, whatever it might be. All right, so here are some of the aspects of programming that we're going to cover today. We're going to talk about control logic. We're going to talk about iterative operations, loops, right? For those of you who've done loops. We're going to do some error handling, and then we're going to talk about what you might call routines, right? Reusable code. This is our functions, stored procedures, and triggers. Okay, so first thing we want to do, we want to talk a little bit about the fact that SQL is a declarative language. It's not a procedural language, right? In a procedural language, we very much define how we're going to do everything, right? In a declarative language, it's more human-esque structured, right? We say, I want you to give me all the rows where where a value is greater than 5. And then we let SQL figure out on the back end how to optimize that and how to best do that, right? We help it the best we can, but ultimately it's doing all of that stuff in the background for us. Well, that means that we don't really worry about some concepts in SQL that we do in a more declarative language, maybe C# or Python or something, right? So we don't really worry about arrays or classes, for example, although some people do sort of try to think of like a row of a table as a class, but and I can see that, but that's not what we're going to go for here. And so for SQL, your primary use for data structure are your tables, right? That's what you'd think of. Whereas in another language, you might be using classes for your data structures. You might be using other ways to store your data. And then in SQL, we've got procedures, stored procedures, we've got functions and views, and those are really our containers. There are methods for how we're going to use reusable code. Okay. All right. Now here is a quick list that I thought of regular programming concepts. I'm sure we could find more. Maybe you should find some. I don't know. But here's what I thought of, right? And here is, you'll notice in the middle column there for SQL support, from my view at least, if those concepts are fully supported or not within SQL, right? And part of the reason I was doing this is so many people forget that SQL really can do most of the things that we do in programming, right? I mean, you're not going to go write a game in it for, graphics on your display, but in terms of data structure and sort of handling flows and controls and things, we have most of the things that a full-on sort of language would use, right? Or at least we have a facsimile of a way that we can achieve the same sort of thing. All right. Okay, you're welcome to look at this table in detail later in the examples, but that's all I'm really going to say for that. Okay, so let's get started on the control logic. So this is how a program or a process decides what to do. It's essentially the decision-making or brain that directs the flow of execution, okay? So this is what gives your program, your script, the ability to kind of make decisions, right? This is where you give it different paths that it can take based on what's going on, right? Now, we have two main components for doing control logic, and one really does provide more control than the other. We have the if-then, else statements or blocks, and we'll talk about more, but this is where you can say, if my variable equals 5, then run this SQL script. If my variable is greater than 5, then run this other SQL script, right? You can take your code in whole different directions and provide different scenarios for what it should do, right? Excuse me. And then in the case statements, they're kind of like if then else statements, but they're built in line. They're nested into our code, right? So you can have them nested as part of one of your select fields or even in a join or things. We're going to show those examples. But the point being that they take place in different places and they have different purposes, even though they're sort of kind of the same, right? And let's look at the if then else's first, okay? You can use these for the conditional logic. You can use them for error handling, right? If you know that a value should always be a positive value and you're getting a negative value, you can do an if statement to check for that and to handle it or to provide an error or to do other things, right? Branch control flow, that's kind of what we were talking about before, if it's this or that, do this or that, okay? You can help provide security, you can do other things. Here is an example of what an if, an else if, and an else statement would look like, okay? So in this one, it's just a super basic example. If we have a variable called credit score and we have a variable called credit rating, we want to set that credit rating to a text value that matches the range for the credit score that we're giving, okay? So we're going to set the initial value of that credit score to 720 in this example, right? But first we write if, and then we write begin. We're going to begin our if statement, and then we're going to write end for the end of that, and we're going to do all the things we want to do if that's true between that beginning and end, okay? In this case, we want to set the credit rating and say excellent if the credit score is greater than or equal to 800, right? And then we're going to say it's good if it's greater than or equal to 700, and then we're going to keep going down, right? And it's important to note, I think you already know this, but it's going to execute from top to bottom. The first one of these that it finds that's true, it's going to execute that one. It's not going to execute the things after it, right? In SQL, there's not a default option that gets executed no matter what, right? The closest thing you've got is the else statement for if none of the other things matched, then do this under any other condition, right? Okay. So that's kind of a quick little example there. I will tell you, when you're writing if statements, you will see examples out there where people don't do the beginning and end, or the begin and end, especially if they're going to write it all in one line. I will just say from a maintenance standpoint and things, I still very much prefer to do the begin and end. I like it to be visible exactly what's going on with no guesswork. And I find that it also helps prevent errors. So while you can do it the other way, to me, this is a best practice, okay? All right, so let's talk about the case statements. This is where we're going to be in line, where we're going to be inside of our code instead of outside of our select statements, okay? You know what, I'm going to step back for a second because I think it's important that while this is a super simple example, right? In that begin and end, all I did was set the variable to a value. I do want to mention you can have huge complex amounts of code between that begin and end, right? You can have select statements, you can have adjusting all sorts of variables, you can be inserting out to other tables, you can be doing updates, right? Like you can have all sorts of stuff between that begin and end. I'm keeping stuff small here because we're on a slide, right? Okay, I just want to make sure that was clear that you can do a lot between those sections, okay? All right, so let's talk about those case statements. I found this analogy, I don't know that I love it, but I'm going to read it anyway. You can think of a case statement as being like a Swiss Army knife for SQL, right? You can cut the data into categories. You can screw values into custom order. You can clean up missing values by providing default values, or you can help measure aggregates differently depending on different conditions and scenarios provided, okay? And we'll show you what that's kind of trying to illustrate here on this next slide, right? Okay, so here is a case statement used in several different ways for some code examples for you, right? So like in that first one, in categorizing, we're just going to do grades for students, right? If case, and just like the if statements, we work from top to bottom. The first one that's true is what gets executed, and then nothing else in the case statement gets executed, okay? So in this case, you've got your field names, you've got your student, you've got your score, and then we do comma and we say case. Look, we're going to do a case statement here. When the score is greater than or equal to 90, then grade is an A. When it's greater than or equal to 80, the grade is a B, 70 C, otherwise an F. Boy, they don't get to have Ds, I guess. And then end as grade, right? That as grade is saying that call this column when the results are returned the grade column, okay? Really, it really is pretty much that simple, right? Now you can have, right, like there's just a singular thing here where score is greater than or equal to 90, but you could have an and you could say and attendance is greater than 90 than an A, right? Or then you could have another where statement that said where score is greater than or equal to 90 and attendance is less than or equal to 80, the grade is a B minus, right? If attendance is worked into your grades, that sort of way. But the point is you can have more than one thing in that case statement that builds out to what defaults to what that then statement should be returning, okay? You can also use case statements in aggregates. So if you're doing a sum, in this case, we want to know how many males or how many females employees we have, right? You can do a sum, but then you can do a case of when the gender equals male, we've got 1 and otherwise 0. That means every time a record comes through for a male, it's going to go 1. It's going to sum that with the results. So if we start with 1, then we go on some more records. We've got another male, so another one. So okay, we've summed up to 2 now, 3. Okay, so that makes a really kind of quick and descriptive way that you can take a columns value and treat it like something else, and then aggregate it for reports or for dashboards, and for all that sorts of stuff, right? Okay. You can do case statements also in other places, like in this third example here in the order, right? We're saying that if a category is premium, then 1, if a category is standard equals 2, otherwise 3, and we're going to order by that. That would provide you a way to be able to do an order for if you don't have like an alphabetical way or a standard numerical way that you can order your results by. So that way you could, take things that can't just be ordered descending or ascending easily, and provide a way to sort of force that to happen still. Okay. Same thing with updates, right? We can say to update the shipping method, how we want it shipped based, in this case, on what country it's going to maybe, or where it's coming from maybe, right? And this would update all of the orders in the entire database because there's no where statement. So I want to call that out. If you only wanted where orders came in today, you'd want to do a where orders date equals today's date, right? Okay. Case statements can be another way to handle nulls. If you don't want to use the is null function for some reason, I don't know, but that is a common way to use it. All right. If you want to help sort of pivot some information without using SQL's built-in pivot functionality, which can feel a little complex sometimes, this is similar, right, to that sum that we did in the conditional aggregation earlier, where we're just summing based on the different things, and we're saying how many orders we have shipped and pending and canceled, so that we can have a nice, easy report of all those things without having to do multiple select statements and without having to do like subqueries or do other things. We can do it all in one spot right here as the system's going through them all. It really is pretty nice. Okay, here is a couple more examples, right? In this case, we've got a case statement in the where clause. We're saying where the country, USA 1, Canada 2, France 3, otherwise 0, where the country is 1 or 2, right? So in this case, I guess we're limiting the orders to ones that are in the US or Canada. Obviously there's better ways that could be written, but for the sake of a quick example here, I just wanted to illustrate that. You can do case statements in a join also. Here's an example here. I'm not going to dive too deep into these two, and the reason is, especially on the join, you should use this so sparingly. You should do other things. Treat this almost like how I've said subqueries, and not to use them when at all possible. It really limits SQL's ability to optimize and to plan and to know what it should do in the execution path to run this efficiently. So if you can handle these sorts of things in other steps through temp tables, variable tables, or CTEs or something, that is probably preferred in the long run, and it'll be a little more descriptive for you. But you absolutely can do it on join. You can do it in a where clause. They do function. Please be cautious with it. All right. Okay, so let's talk about some more comparing of those two, right? We've got our if then else and our case statements kind of compared here. I'm not going to run through each one of these. Hopefully you guys can pause the video and read through these if you want to. But really it's mostly going to boil down to the limitations of the if then statements being wrapped around code blocks and the case statements being nested in, and what that ultimately means for what they can do within those scopes. Okay. All right, so let's talk about iterative operations. This is our loops, right? Let's go ahead and get started. Well, I want to step back for a second. Okay, so one thing to know is if you're used to other programming languages, you might be used to for loops or for each loops or for in type loops. SQL doesn't have any of those. SQL has one type of loop. Well, we'll talk about two, but really when we're talking about loops, we're usually talking about while loops. And that is, we run this loop while a condition is true. And once that condition is not true, then we stop running the loop, okay? And so that's how that functions. Here's a quick example. So in this case, we're declaring a counter to count the number of times that we've gone through our loop, right? And we're saying while the counter is less than or equal to 5, so we're saying we want to do this loop 5 times, presumably, okay? Print a message. We're going to print what loop number it's on, essentially, okay? And then to the screen. And then we're going to set the counter to itself plus 1. That's what that plus equals 1. You could have also done at counter equals counter plus 1. That would work exactly the same. This is just the shorthand, right? It's shorthand that's common in other languages, C#, Java, and others, for at incrementing a value, right? Now, if for some reason you want to increment by 2, you could absolutely do a plus equals 2, okay? All right, so let's talk a little bit about cursors. These are probably a little less common. You'll find them more in older SQL writings. Most of the time when I come across them, they're for stuff that stretches clear back to the 90s, early 2000s. Okay, that's not to say that they're bad or that they're not used anymore, but I think most of us are used to how a while loop feels because of either other programming languages, and just the visual paradigm that it gives us can sometimes be easier for a lot of people to follow. Um, Here's an example of doing a loop sort of functionality through cursor, right? In this case, we're going to declare a variable name of employee name. We're going to declare our cursor. So our cursor needs to be a variable itself that we work through, okay? And in this case, we're going to say the employee cursor is for, and then we provide a statement that it applies to, right? So in this case, we're saying select the employee names from the employee table. And that is what is fed into our cursor, all right? Now you can absolutely have more than one column, sorry, in that cursor, and you can work through it that way. But for a quick example, we're just going to use one. Okay, so then we open our cursor. All right, that's going to tell SQL, all right, let's get to our first row. Okay, and we're going to just say fetch our next one from the employee cursor into employee names. Right, so we're inserting the name into there. And while, so that's what we're going to do with it anyway. So while our fetch status equals 0, that means while we're still fetching, that means while we haven't had an error or an end or something happen or occur, we can print the employee name and then keep fetching the next one from the cursors, right? And so in this case, I ended up using a while loop anyway. So I don't know. I would probably in this case skip the cursor and just build it out and build some variables on top of my while loop. But it's here. Make sure at the end that you deallocate your cursor so that the memory can be freed up and the computer knows, and the SQL script knows to move on, that you're done doing the looping function through that, okay? All right, here's some more examples of using cursor so that you've got some code examples that you can look through and refer. Really, this is just mostly one example. The left here is to help you set that up, right, to create the table. And then the right is you doing the actual cursor, okay? All right, so let's compare both of these real quick. But before that, I want to touch on the fact that while loops are available in SQL, and I'm not saying you should be scared to use them, they should be used thoughtfully. SQL's performance is way better for doing things in sets, right? That's what it's built on. That's what it's sort of made to handle in a great way. So anything you can do in a set operation, in like, not a set, in aggregate, you should be doing, right? If you're wanting to update, and actually I've got the example here. I'll just read through this. Okay. So in SQL, like, you don't have to treat each row separately and loop through it to do something. You can update an entire table in aggregate. So in this case, I wanted to give a quick example of, if you wanted all first names to be in uppercase, you can just say, update my table set first name equals upper and the first name, right? You don't have to worry about saying, okay, record 1, update that one, record 2, update that one, record 3. Okay, SQL is going to do all that on the back end for you, right? And it will do this way more performant than you can write a loop to do it in SQL. And it'll be simpler and easier to maintain. Okay. All right. So here is a couple of code examples for each approach of dealing with rows in plural of data, right? We've got cursors, like we talked about a minute ago. We've got set operations. We've got while loops. Each have their pros and cons and their places. Order of precedence, if you can, do anything you can in the set-based queries. If you're not able to do that for some reason, or you need to fetch different results to do all sorts of different things, then move to your while loops, I would suggest. You can look at cursors at that point, but honestly, if you stick with those two, you'll be pretty solid, and then you can move through the stages at that point. And if you come across the scenario that those aren't working, you'll know it. You'll start Google searching or asking Copilot or something, and then it's going to say, hey, you could try a cursor for that, and you'll know, right? I don't want to downplay cursors, but really with while loops and set-based queries, you're 99.9999% of the time, that's what you're going to want to use, okay? All right, here is the comparison, right? You've got some pros and cons and best use cases for when to use them. I think we've already kind of hit on these as we've gone through, so I'm not going to bang on them about too long. All right, so let's talk about error handling. For those who have done other languages, right, there's this concept of having try catches, or right, and SQL has that built in. It's great. It works nice. You can definitely, that way, if your script has an error and you have a try catch block wrapped around it, your script doesn't have to fail, right? Or if it fails, you can have that information dump out to somewhere. You can gather other things. You can do other actions before you end the script that might help your troubleshooting, or it might help get data in a better place for when you pick back up. This is really a good best practice for when you're writing SQL scripts that are more complex and might have things that are prone to failure, like maybe you're casting data types and that might not end up being compatible or something, right? There's all sorts of things that could happen. But they help ensure graceful failures instead of crashing. They help maintain our integrity. We haven't talked too much about transactions, but you can absolutely roll back an entire transaction if you need to using these. or decide what to do. You can provide custom error messages that are more verbose, or that are verbose isn't the right word, more reader friendly, right, as to what went on, so that if the error message is passed to a report or to a front end application or an automation or a log or something, people can know specifically what happened, where it happened, why it happened, and all that kind of information, right? All those things that can make somebody's troubleshooting job go from, minutes to hours to days down to hopefully seconds or just minutes, right? Great information. So we've got try blocks. This is where we're saying, hey, try to run this code between the beginning and end of this try. But if something happens and it doesn't go right, then let's go to this catch block and do what we can there, right? And that's where you're saying, because we couldn't do this first thing, now let's do this thing instead. Okay. Throw, we'll talk about those in a second, but throw is where you purposely throw an error. Maybe, if you have a table of inventory items and you know that a field should never have a negative value, and a negative value pops up, that you want to throw an error, you want to crash things because you want to make sure nothing gets modified, because that should never happen. You can forcibly throw an error just the same as if the system threw an error, and provide your own error message and other things, right? Okay, so in that case, you can use these to help enforce business logic as well as like system-related errors. All right, and then we do have some error functions. We'll show examples of those, but these are how you can get information about what happened in your error, right? Error number, that's going to be the SQL error number that sort of associates it. That might be like the error number that you throw into Google sort of thing, right? The error message, that's going to be the error message that SQL Server returned back. Maybe it's, I couldn't convert this text string into an integer, right? Because somebody put a name in there on accident or something, since it was being stored as a string. Okay. Error line, that's where you're going to return the line number of where the error occurred. I will tell you that that line number is oftentimes approximate, right? If the error happened in a long select statement that has many rows in it, or lines in it, it might just give you the line number of the beginning of the select statement instead of just the exact line in the select statement where it happened. Okay, but that gets you a lot closer. You know exactly what select statement threw the error, right? So you're still on a good track there comparatively. All right, so here's an example. Here's some other information I wrote about. You can definitely pause and read those specifically. It's a lot of words to have on a slide. Okay. Here is an example of a transaction. I know we're not covering it much. Maybe I'll do a supplemental video at a later time that kind of talks about it more. But more importantly, what it's showing us is how we've got this begin try and end try, and then we've got this transaction. What we're saying is we've got these things between these transaction markers that are all together. And what this is going to do is, if there's an error, then when we hit that catch block, we have that rollback transaction. Now, what that means is, so let's say that first update statement, the updated counts at balance equals balance minus one, let's say that ran successfully, right? But that the second update statement had an error. In this example, maybe there was a divide by zero or something, I don't know, right? But if your second statement had an error, and you know that you don't want that first update statement to be committed unless both of them succeed, this allows you to roll back the changes that were made from both of them so that you can be put back into the state that you were in before you did either of those updates. All right. And then in this case, we're printing out the messages of, the error message information that happened. Okay. And then at the end of this catch statement, we're still, see that throw statement? Now this throw statement doesn't have any other information attached to it. So what it's going to do is it's just going to throw the error message that caused the catch to happen, right? And so in this case, this script is still going to error out. It's still going to return back that this script failed, but you were able to still sort of gracefully handle it, and we're able to roll back the changes that we didn't want in place because the other changes failed, right? So it's still a better way to go, even though we're still crashing out, because we're still able to be clean about it, okay? All right, here's another example, a very basic one, right? So if we declare an integer, or we got two integers, and we try to divide them, one of them 0, that's obviously going to fail in that try block, right? You can't divide by 0. So you're going to land into that catch block, and same thing is sort of in the other message, right? Error occurred, the number that happened, and where it was. You're going to print those messages and then still throw the error. Now, I will say, just as an example, I've had times where I did the try catch blocks, and instead of throwing the error back out into SQL here, I wanted the SQL script to look like it succeeded, but I had code in there that would kick out an email to us that there was an error, and it would tell us what record, what the customer's information for the customer, and it would give us the line number and all the other bits of information. And so that way we could just get the email, we could go back, we could handle it, but users didn't have to deal with their application crashing or the report not running, right? Here's another example. This one is just, I wanted to give you an example that showed most of the messages that you can get returned back, right? So we've got the error number, error message, the error severity, the error state. Error procedure. So if your code is running in a stored procedure or something, it will return back what procedure it was that had the error, so that you know where to go looking, okay? And then the line number within that procedure that it happened on, all right? Okay, here's another example. I wanted this example to show you that you can do try-catch blocks inside of try-catch blocks, right? So we tried this thing, it failed, but that's okay. We know that's gonna happen sometimes. So try this other thing, and we're only gonna error out if that one errored, or maybe we still want to go even deeper and try another thing and only error out if all three of those had failures, right? That gives you a path to try several things before you really have an ultimate bad crash, okay? Excuse me. Here's another example of it nested. This way I can get a little more vertical and you can see it a little better, but same thing. We're just saying you've got an overall try-catch. Inside of that try-catch, you've got another try-catch, right? So that you can try different avenues and try different things. Okay, so here is an example of throw. Now, for those of you who've been doing SQL for a while, if you've ever done these, you'll know that there is an option for raise error. Just know that Microsoft wants to phase that out. They haven't yet. They probably never will totally phase it out because they don't want to break stuff. But the point is that throw is what they want us using now, right? And honestly, the look of it just looks nicer, just code-wise, right? So that 5001 I've got there, that's just me giving my code an error number. Okay, something to go search and something to be returned, so we know where to track things down. And then something went wrong. That's just the error message. Make it descriptive, make it informative, make it something that makes everybody's life a little bit easier. And then, yeah. So, okay. All right. So here's a comparison between raise error and throw. Just use throw at this point. But I wanted to talk about raise error, at least give you an example in case you come across somebody else's code where they've used it before. That way you can know that it is there, and maybe you can take the opportunity to update it a little while you're there. Okay. All right, so let's talk a little bit about routines. These are our functions. All right, we've talked a fair amount about built-in functions in SQL in previous lessons, and we've definitely used them in pretty much every lesson to this point. There's stored procedures and there's triggers. We talked a little bit about triggers when we talked about tables. We didn't get into how you create one, but this concept that you can run code based on if somebody's trying to take an action on a table, right? So why do we use routines? Here were some reasons that I thought of, right? One of the big ones that you'll come across is security. And this is because when you're calling a stored procedure from other applications, they can call the stored procedure in a way that makes it much more resilient to things like SQL injection, right? And they can do things where they parameterize the inputs that the user's allowed to submit and can scrub and clean them and things to help mitigate potential SQL injection and other types of attacks, right? Also, they just make it easier, right? If you have a stored procedure that's called get all active customers, it's pretty clear what you're doing when you run that, right? As opposed to having a script that, maybe you've got some convoluted set of tables to get what seems like a simple bit of information. And then performance is definitely a boost, right? With stored procedures and I guess I didn't consider views in here that well, but with stored procedures and views and functions and stuff, SQL is able to see what you've got going on there, and it's able to sort of optimize for it because it knows that you're going to be asking for those things. And so it's able to be prepped for that and to handle those requests a little faster. Reusability. I mean, if you've got something that you can reuse across different platforms, right? Like I've had stored procedures that a web page dashboard used the same stored procedure as a report that kicked out some PDFs to people, as a program that was using it to generate other things. And across the board, it meant that all those things were able to share one code base for how data came in and out of the database. It meant that they were uniform. It meant that troubleshooting was sort of in one place. It meant that the data was consistent going to those places. It makes the code highly auditable. It's a lot easier to audit SQL stored procedures than it is people storing code within, Power BI reports or Crystal reports or a compiled application and other things. Okay, you can help control access. One really nice thing is that let's say that you've got somebody you want to be able to do some very specific actions, and
in order to do those actions, you'd have to grant them rights to a bunch of tables, and you'd have to give them insert rights and other things. And maybe you don't really want to do that, right? Like they don't need to be able to do that all the time. Well, you can give them rights to a stored procedure or a function or something that can do that. They have rights to that stored procedure, and that stored procedure can execute those actions. But that means you don't have to give them all those rights to those actual tables and everything. Okay, so that tends to work out really well for security, and controlling access. There's the level of abstraction. It's super nice that, let's say you've got a report that has 5 columns, and somebody updates the application in the background or the table schemas, right? You can go update that stored procedure to point to the new schemas and to handle all that, and still return those same 5 column names. And that means that none of the other processes that were pointing to that stored procedure had to ever know or make an adjustment that something happened on the back end. Okay, and it means that you've got one good place to make those changes. Reusable code is a great way to go. So let's talk about this a little bit more. Some more things we've already talked about. Okay, so functions. You'll hear the term UDF. That's short for user-defined functions. And user-defined functions is just our long-winded way of saying functions that we created, functions that aren't just built into SQL. Okay, so this is where we can create. So remember that function you've got like upper, right? And that one makes a text string all uppercase. This is where you can make your own functions that you can include in your SQL to do different things. Maybe you want a function that formats numbers into a specific format to match things like phone numbers or social security numbers, or maybe you want a function to parse out a name from first, last, and middle, where those things are normally just stored in one text field, right? And you've got all these other different things. We have 2 types of user-defined functions, really 2 types of functions. You've got scalar functions. That's just a way of saying a function that returns a single value, okay? That means a function where, in the example here, we added 2 numbers, we returned another number. 1 plus 2 is always going to be 3, right? If you concatenate 2 strings together, you're going to get another string back, okay? That's your scalar functions. You've also got these table valued functions, or sometimes they're called tabular functions, or TVFs. This is where your function is returning a table, right? You've got data with multiple columns. That's basically it, okay? So you could use this in a lot of languages. You can have like Drupals or something, tuples, where you return more than one variable back at a time, or you return a set back. In SQL, you're doing that by returning a table back, okay? So here's an example of creating a function. You say create function, you say what schema and the name of the function, and then you're going to do parentheses. Inside those parentheses, you're going to give the names of the input or inputs for that function and the data types for each of those, right? So, and then you're saying that we're returns a table. So in this case, we're selecting an employee ID, the employee IDs and names for all the employees that are in a department. So that's one example. For me, I think I would do this exact scenario probably in a stored procedure more than a function, but it does work here. Okay, so here is a couple more examples of scalar functions, right? Here's one to help format phone numbers. Here's one to do an age calculation, right? Based on the birth date and it's going to be based on the current date. So in this case, for that function, you would supply the birth date and it would return back the age of the person. Here is some TVFs. Here's another example of using a function to parse out names. This is a very basic name parser. I've written out some name parsers that can get pretty complex, and I do them in functions, but it's able to determine like Mr. and Mrs. It's able to determine junior, second, thirds, multi-part middle names, other things like that. So, but this one for most use cases would work out all right. Here are some example uses for when a lot of functions could be used and for why you might use them. Benefits. Okay, stored procedures. This is probably the one that a lot of people, like when you're building an application, when you're building a report, when you're building external front ends that people interact with, this is the guy you should be thinking about, the stored procedures, okay? Instead of having any of those things running SQL directly against databases, in most cases, if it's possible, they should be hitting stored procedures. Like we said before, it's better for security, it's better for performance. It also removes that logic outside of the application so that it can be edited and audited there. And it gives you the abstraction from the different front ends so that, I don't know, maybe you wrote the report in one tool, Crystal Reports, and then you're trying to move tools to another tool like Power BI or something. And this would allow you to still retain all of that business logic, to retain all the things that you had going on there, but just another tool to be generating the outcome or the PDF or the online dashboard, right? Here is an example of how to create a stored procedure. It's pretty similar to creating the function, really, almost exact, except for you're saying create procedure, then you're giving the procedure name. You're going to give the input variables for that procedure and the data types. You can have multiple of them, just separate them by comma, just like you would if you were creating a table or something, right? And then you do the keyword as, and you've got a begin and end, and then everything you're going to have that stored procedure goes between that begin and end. So here's a couple examples of those. I'm sorry, I didn't format the ones on the right-hand side. Nice. Okay. Here is, different types of stored procedures that are in SQL. When you're creating your own, you're probably creating user-defined stored procedures. That's probably the only one that you're really, this guy here, the only one that you're really thinking about for those. The system ones are already built in. The extended procedures are already built in. Those are just part of SQL. You may or may not have access to them, especially the extended ones, because those can allow for things like running command line commands on the operating system of the SQL Server and other things. So usually those get pretty well locked down by the DBAs, right? And for good reason. Now we've got this other guy called CLR stored procedures. This is if you want to create a procedure to happen to extend SQL's functionality that it doesn't normally have built in. But you would do this creating it in like C# or VB.NET or something, right? I've done a few of these. One example was they needed the SQL Server itself within some stored procedures and stuff to be able to interact with some APIs and to send some information in JSON and to return some information in JSON and to parse through that information. I've done other ones with XML also, and do some things. And I don't want to get into why, but it was determined that the SQL Server needed to do that. And so SQL Server at the time especially didn't have functionality for JSON. It barely had a little bit for XML. It certainly didn't have the ability to go hit an API at a URL, like a web address. So we built a CLR stored procedure that you could call and feed some information. It would go hit that API, return back the information, and then parse it and do things. So if you ever get to extend SQL Server, that's functionality, that's how you're going to do it. One thing I like to do with my stored procedures is right near the top, I'll usually have a table. I'll call it like @t final results or @dt final or something. And that is where I create a variable table or temp table, usually a variable table, of what I want the exact results of my stored procedure to be at the end, assuming that the stored procedure is returning a table, right, of results. That does a few things. One, it helps right up top to know what I expect to come out at the bottom, right? And that gives me my building guide for what I'm aiming to construct throughout my SQL script. And it becomes my blueprint for what I need to work on all those steps to get to the outcome. It also gives somebody else, as they're coming to look at this code, the ability to see what they should expect to be the outcome. Okay, and it makes them for a nice place that you can add comments next to each of the columns and do other things. Right here is, oh boy, I shouldn't have called these steps. So tip one, that one. Tip two is if you want to use a stored procedure within a stored procedure, or you want to use a stored procedure and then massage its results somewhere else, you can do that. But the way you have to do it is to insert its results into an existing table. It can be a temp table, it can be a variable table, but it already has to exist. And then you can massage the data results from that as you need it afterwards, right? That way, as you'll see in this tip 3 one here, if you do this, then you can do a select star from customer orders. That's because you can't do a select star from a stored procedure. It's just not built to let you do that. So if you want to be able to do that, you've got to insert the results into something and then select it out from there. A couple of tips. Always formatting, try and keep things formatted and keep good comments so people know what's going on and things can work well. Try and keep operations you do as set-based. We talked about that a little bit with the loops, right? Try and do things that way rather than doing cursors or loops when possible. Parameterize your inputs for your stored procedures and make sure those inputs are the right data types for what you expect. Don't accept strings for everything or varchars, right? Text. If you know it's going to be a birth date or if you know it should be a number, right? That's going to help the security. That's going to help the performance. That's going to help so that you don't have to parse that information out and have potential errors throughout your script afterwards. Okay. Keep some good consistent naming conventions. We've talked about naming conventions in previous lessons. Same things apply here. And within your stored procedures, remember, this is a great place to do your error handling, like the try-catch blocks that we talked about. In fact, this is probably more important than if you're just running a script from something on your desktop. Okay, now at the top of stored procedures, there's some lines that quite often get added, and so I want to throw those here just in case. So this set no count on. This is, if you turn this on, it removes those SQL messages that you get that say 5 rows affected, 25 rows affected, right, for what was going on. And especially if you have a SQL script that's doing a whole lot of things, you can get a ton of those messages built up, right? And maybe you want to see those sometimes. But if you're doing an application or report or something, some tools don't like those messages. And so they actually treat those messages as the results before the results are returned. And so for some applications, you want to go ahead and set that no count on so that you don't see those, okay? And set ANSI warnings on or off. Turning those off helps remove messages like null values are eliminated from aggregates, right? So let's say that you're doing a sum on a column and some of the columns you have in there, or some of the rows in that column might have null values. You would end up getting this error message back. And just like the other one, maybe you don't want that error message. You're fine with there being nulls that aren't calculated into the average or into the sum, right? Then you're going to turn that off so that it doesn't bug other things out, right? But there again, you might have use cases where you absolutely want to see that because you want to know that there was nulls there when there shouldn't have been or something. Or maybe you want to use one of your if-then blocks or your try-catches to try and handle them a different way. Okay, and then these ANSI nulls on and off. I've different applications like them differently. I would say start off with not declaring either one of these, and then if you're getting errors, you can throw it in and change the value back and forth and see if your application needs it. Most applications deal without having to have this set at this point. Okay, but this would be like if you wanted to return null null when there's a null value, or if you just want null treated as empty. All right, here's some common uses for stored procedures. I think we've talked about them a little bit, right? But here are definitely other use cases they could think of, and when you might want to use them. Benefits, we've hammered on these already a little bit, right? Performance, security, reuse, and easy central maintainability. You can build in error handling into it. It's better for auditing and logging. Also, it makes it so that, if, let's say you've got a report worth of data that you're getting out, but you also want to log when your report began and ended, maybe that tells you sort of some performance information, right? Or other useful things, various steps in your process. You can absolutely be logging those out so that you can have a historical record and things, okay? Stored procedures are preferred for what you're using when you're interacting with applications by far. And like we said, this shields applications from schema changes. That's the abstraction that I was talking about before, right? Where they don't have to care that things change. They just know that they're getting the same results back. And the stored procedures, you can kind of think of it almost as like a SQL version of an API. And then you can do transaction management. That's that where we can commit a whole thing or not commit the whole thing and roll it back, or, based on different conditions that happen. Triggers. Okay, so triggers are when we want to take an action on a table when something's done, right? So these are sort of like stored procedures that automatically execute when a table is receiving a command for an insert, an update, or a delete. You can do these to help enforce business rules. You can help them to massage data before they land in the database. Maybe your front-end application has changed how it sends a gender code or something. Maybe it used to say male and female or decline to answer, but now they're only sending like M, F, or U, right? Or something. This would allow you to capture that and to still translate it into those longer string ones so that you can have consistency into your table, even though you're receiving different results because they couldn't change it on their end, right? You can also do auditing, right? You can say when information is being updated in a table before it's updated, you can log it out somewhere else so you've got a historical record of what was changed, before and after snapshots. You can do all sorts of things. It'd be super handy. When we're working with triggers, there's an interesting thing that happens, right? You're doing an update on a table, for example. Okay, I'm going to pick update for a very specific reason here. Well, when that action is happening, there are kind of two other tables that get created. At least in our brains, we can think of it that way. SQL's not really creating tables, but one of those tables is called inserted, and one is called deleted. Inserted is what our new information is. That's what is actually going to go into the table on an insert or an update, right? Deleted is this table of what the values were before we made a change by updating it or deleting it. And the cool thing about SQL keeping these when this happens is that it means that we can tap into them and use them in our triggers. Oh, real quick. So here's the different actions, right? The CRUD actions. And here are what pseudo tables get created when those actions are being run, right? So if you're doing an insert, the inserted pseudo table is created. When you're doing a select statement or read, there's no need to, nothing's changing, right? If you're doing an update, we get inserted and deleted created because an update is, in a way, an insert and a delete, right? You're deleting the old information and replacing it with the new information, at least conceptually, right? And then deleted, of course, this deleted pseudo table is created. Another concept real quick. So we can define when our trigger kicks off, okay? We can do it after the action, so after insert, after update, after delete, right? Or we can say instead of doing the insert, or instead of doing the update, or instead of doing the delete, do it. Now, in Microsoft SQL, there is no before insert or update or delete type actions. You're going to use the instead of those, right? The instead of is our beforehand capture instead of before, okay? So here are some quick examples. Here's us creating a trigger on a table called orders, and we're saying to do it after the record has been inserted already, right? Then we're going to insert some information into an audit log about what we just inserted also. So that way, if orders ever gets updated, we still have a past record of exactly what it originally had in those values, right? And when it took place and who did it. Same thing with update, right? But now we've got select from inserted, right? We can throw an error, and same thing, we've got transactions we can handling, okay? Deletes, same thing. Here's from our deleted pseudo table and what we want to do. So we're saying if we delete an order, in this case, we want to delete all the order details, right? So if I had an order in Amazon where I had 10 things in my shopping cart, right? And I went and I ordered that, and then I go, oh man, I changed my mind. I don't want that order anymore. And I go and delete that order. Well, we don't want a bunch of orphaned records of all the tissue boxes and Tylenol and whatever else I had in that order, right? So we're going to go through and delete all those items that were, all those details that were in the order so that we can keep things clean. Apparently I forgot that I made these little highlighting blocks so that we could see those, the inserted and deleted pseudo tables. Right, so here in this one, before we do an update, right? So we're saying instead of update. So somebody said, hey, I want to update this record in a table. And we're saying, whoa, nope, SQL, you're going to do this instead of the update that they asked for. Okay. So in this case, if we have something that they tried to update and things weren't right, we're going to throw an error and we're not going to do it. But if things are fine, then we're going to go ahead and insert it. Another before example, right? We're using the instead of insert instead of using the before, same sort of things here. Just giving you some examples to work on. Okay, so here are some of our routine types compared. And guys, I really want to apologize. I meant to have views in here also. So maybe I'll tack views, a little segment about views into the last training. I mean, I guess we touched on it a little bit during temporary items. So maybe that's why I didn't cover it here. I'm going to give myself that excuse. But here's kind of when you would use each one, quick description of them. Functions you can think of, this is like our kind of like the case statements, right? These are our things that we want to be in line. They're the things that are nested into what we're doing. Stored procedures, this is where we've got a whole thing we want to do. It can be one select statement, it can be 200 select statements, it can be updates, deletes, backing up databases. You can do anything you can do in SQL statements, you can do in a stored procedure pretty much. And then triggers, again, this is what's happening. We're saying, hey, when this table has an action being taken on it, then let's go ahead and do it this way, okay? Or do this instead. All right, well, guys, that's the end. Thanks so much for hanging out through this. And as always, if you guys have questions or if there's stuff we can walk through, let's get together. Let's walk through it. Let's make some examples. We can, if there's not a real example to walk through, we can make one up and have a good time, or at least I'll have a good time. Maybe I'll have a boring time. I don't know, but we'll have a time. And I hope that this is useful. I really, even if you're not able to do stored procedures in the routines, views, triggers, and functions, because you'd need to work with DBAs to get those built in, even though I think it's totally worth doing that. But the other things, please take away doing the try catch blocks. Please do the if then else and else if statements, right? Those are all things that can really help your code, that can really help bring some of the business logic into SQL when that business logic is based on data, because SQL is really good at that. And it can make that part of stuff a lot easier so that you don't have to be doing that in code or in other ways that other tools provide. You'll get performance benefits. It'll be easier to maintain, I promise. Anyway, thanks and have a great day. Bye.